Hi, today we're going to show how to inherit from a class in C++. I have on my screen a UML diagram that I've drawn on draw.io, and it starts with a parent class called account. And account has 4 properties and 3 normal methods plus the setters and getters. You see that I've inherited checking account off of this and loan off of account. Both checking account and loan will have the same 4 variables, plus they'll have these method functions, but checking account will add functionality to account without breaking account, and it'll add this idea of doubles and a function called apply fee. Loan, you see, adds 3 difference variables to the class, adds a number of other methods as well. But both of these child classes will have the same member variables and member functions that account has. All right, I'm going to do this in I'm going to use in Visual Studio Code. So I have my account class built here. And as I've commented here, anything that's private will not be inherited by your child classes. Anything that's protected can be, depending on how you set it up. The way we'll do it will be. And anything that's public is guaranteed to be inherited down. I've got my standard setters and getters. So let's create a new class. I'm using that cool tool I showed you. So I'm going to call it the checking account class. And checking account is created here for me. And now I need to inherit off of accounts. Do so, colon, public account. You also need to make sure 2 things. 1, that they're in the same folder. And secondly, you included the proper item. So by default, I got public private here. I'm going to add in my protected. I use protected for all of my classes just because I know I'm going to inherit later. If you don't think you're going to inherit later, don't use protected. So I've got a fee that I'm going to set, and I need the new public variables. You always need setters and getters. That's just good code. You need a parameterized constructor. You should create a toString. It's technically optional, but it's always a good move. And I should have a toString generated here that I'll use. I do. I'll use my parent toString in my child class. So let's set these up. I only have 1 protected variable, so I need 1 setter, 1 getter. Now, a base setter is simply this. Make sure I give me a different variable name there. That's really all you need. You can put logic in here. Got this wrong. So if the variable you're passing in is bigger than 0, less than 100, and I just made those numbers up, so I can put some logic in to defend my variables. I can set my class fee into what I pass in. If your users pass something wrong in, set some defaults. So this will say you can't have a fee of 0 and you can't have a fee of $100. Anywhere between 0.01 and 99.999 is legit. Assign that to it, otherwise set 10 to be your fee. And since this is small, I can throw this inline. If you don't like inliners, you can set them over in the CPP, and I'll do the next one there. Getters are always the variable type of the class, and you simply return it. You can get real clever here and do a peek, which will open this up in another file. Or you can just go over to checkingaccount.cpp and add it in. Forgot the data type. And again, that peak thing is pretty clever. I click peak definition, and it opens up the checking account file right here. Depending on your setups, there's some keystrokes that do that as well. Okay, so I need a parameterized constructor, and I will build those over in my CPP file. So the parameterized constructor is different. Even though there's only one variable here, since I inherited off of my accounts, and that public account is the default, but it gives me everything from protected and public down, that means I need to account for these variables. Those variables have to be my child class constructor as well. So what I'll do is I'll take this that I wrote before, copy that because that's my parameterized constructor prototype from my parents. I'll build that here. And then that was for my parents, and I need to add in the fee for this one. I'll wrap text in this so you can see it. So these are my parents' variables. This is my child variable. I've passed them in. All right, let's code this. You can do it here. It's just really ugly to do it inside this file. So I'm going to go over to my CPP file. And you see how I set this up. Put your variables in, and again, I'm going to press enter so you can see what I'm doing. But now this is where this gets clever. You need to call the parent constructor. So do so with a colon, and then pass in the variables that that constructor wants. These are coming from here, these parameters. And then curly braces. Again, press enter here so you can see it all. Now you might have noticed, those who were paying attention, I didn't call the parent constructor here. I have to do that. So I'm going to say my fee equal to $5, and then I'll call the parent constructor. My parent constructor defaults first name and last name to dummy values, but this guarantees me when I create a variable of type checking account, it'll get the accounts defaults as well. And then down here I can just do something like I did before. I did it wrong again. Account number, first name, last name, balance, and fee, those will all be set for me up here in my parent class. Okay, so checking accounts, if we go back to my UML, we see the checking account has a method called apply fee. Let's write that. And then I'll build my toString, which is actually kind of cool. So I'll go to checking account, HPP, I'll prototype it. It's called apply fee, not apple fee. And all fee does is subtract off of the balance. So go to my CPP, I'll implement it. That's simple, all it does. Again, you can apply whatever logic you need here. These member functions can get really complicated. Do whatever it is you need to do to get your project working. Last thing you need to pull off is you need to pull off the toString. My checking account has a toString defined, or will have one, but my account class has one as well that I'm going to use. If we look at my toString, I print out an account number, a first name and a last name, and a pretty looking balance. I'm going to use this back in my checking account class. So let's create the prototype. And then I'll go to my CPP and implement it. Many people write an override in front of this that says I'm overriding the parents. It is technically correct to do so. It doesn't hurt much if you don't. This is technically called hiding the parent class. What I'm going to do here is I'm going to string. And what you do in your toStrings, you just simply create a nice output. These can be used whenever you start to write to GUI operating systems as opposed to the command prompt where you can simply convert this to a nice output. Do whatever you need here. What I'm going to do is I'm going to call the parents. Just got it wrong. Name of the parent class, toString. Now I forgot to put my connection here. That should make it happy. It does. And this will make my outputs equal to my toString. I'll then add on whatever I want for the child class. I'll put a new line there. I'll get a bunch of decimal places in this, and I don't really care for now. You guys can fix that. Oh, it wants me to convert this. You happy now? Why are you angry? Alright, no, didn't like to add the strings together. Okay, so it'll print out the exact same thing the checking account does, but add on that fee. Alright, so that's creating an inherited class. Let's just see what it does for us. Let's go to my main. And I have a bunch of stuff that I did in lecture. I'm going to comment this all out, with the exception of my wife. Could have done this faster. Okay, so I've commented everything out except for Laurie and this outputs. Do a quick run on this, make sure it works. Well, there we go. Okay, so here's my output from my accounts. I now need to use my new project is created. Include whatever you need for your particular language. Here in Visual Studio Code, it likes the CPP file. And so now I'll create a checking account. And I have two parameters for checking account. The overloaded one and the default one. So what's the balance? We'll say we have 1500s, and the fee is $25. So I need a variable there. Call it lecture. So I have a variable called checking account lecture. It passes in these values. And let's see what happens. Quick toString. Here's my fee. I told you there's a bunch of extra dollar signs there, and I'll live with it. What we also get from this, I can deposit. And you may say, where does deposit come from? Deposit comes from accounts. And deposit wants an amount and allow me to add to it. So let's say I'm adding $500. Remember, we put $1,500 in to begin with. When I run this, and now it's $2,000. Likewise, if it's the end of the year, let's apply the fee. We'll subtract 20, whatever our fee is, which is $25. So I should have $1,975. I do. Perfect. So my child class gets access to my parent class objects, which is part of the reason why you inherit. You don't have to rewrite deposit. You don't have to rewrite withdraw or transfer. They're already there because the parent class has it. All right, I'm going to have this particular file up on my GitHub. So if you need to see it, take a look at it. If not, thanks a lot. Good luck.